welcome to one more session of your WOC. This is your Vani ma'am back again with, yes, NEET series. This is your NEET series, day 2 students. So basically today, as mentioned, we'll be studying the very important questions of your thermodynamics. Okay, so basically thermodynamics, major weightage, you all know. So I'll be telling you the tips, I'll be telling you the tricks, and important thing, these particular questions are picked up from your previous NEET question papers, and the most important thing is what I'm going to discuss today. So go through the complete video, and this NEET series is going to continue till your NEET exams. One more important thing, you already know I'm a verified educator at an academy, correct, my students? So if you want to join the platform till your NEET examination, or if you want to join the platform for your JEE, if you want to join the platform for rather 6th to 12th, also no problem, classes also, you can use my code. What is my code? My code is Vani10 or Vani Live. If you're using it before May 19th, you'll be getting 20% discount on the platform. So your NEET preparation will be done. JEE, if you want 6th class to 12th class, you can use my code. So join the platform because courses are going on at the high speed, students. You can get wonderful educators on that. So note my code. Before 19th of May, if you're taking up, you'll be getting 20% discount on the platform. Got it, students? Yes. So I'll be pasting the link also in the description. So go through the link. If you want to join the platform, you will get immediately 20% discount on that. That's the one important. Let's start. Before we start the session, please share the video to all your friends because it is free. Please like the video. If you like, more and more videos would come up from WOC. WOC is a platform which has done almost 1600 plus videos. It is all free, students, for grade 10th, for grade 11th, for grade 12th, for NEET students, and for your JEE students also. It is a free platform. So please like the video so that it reaches more and more. Follow the channel. You can comment whatever you feel after watching the video. And important thing, turn on the bell icon so that you'll get a notification because WOC will upload videos every 3 days. It is going to upload a video. Yes, let's start. So before I start your thermodynamics, remember, I will first taking up the important thing, 2 parts. What is it? I'm going to show you the complete thermodynamics summary. Okay, students, thermodynamics chapter, whatever is there, the complete thermodynamics summary is what I'm going to tell you. Once you get the summary, it is easy, na? Just like your hand note. After that, I'll be solving very important questions. Very important questions from your thermodynamics, which you have to study for your exam. Okay. So this is what is the important thing. Let's start off with the session without wasting time. Let's see. So first, we will go to the thermodynamics summary. Let me show you this. I have given you complete from starting from the definition of thermodynamics, what are the different types of systems, what are the different types of thermodynamic properties with examples and everything. Go through the whole summary so that it will be a hand note for you all. Next, in types, again in that state functions and variables, I have given what are the state functions and variables which are there. So we are also going to study the different thermodynamics processes like adiabatic, isothermal, isochoric, isobaric, cyclic, reversible and irreversible. So all the headings along with what are the conditions which to be followed also I have mentioned here. So in cyclic process, these are equal to 0. In reversible, what happens in reverse. After that, I took to a concept called zeroth law. Yes, zeroth law. Yes, what are the system characteristics? Internal change, what is going to happen? Work, if it is done, what is going to happen? If heat is generated, how do you calculate change in heat? Then comes gradually from there, first law of thermodynamics, where I've given the applications of first law, everything. Then gradually I took into enthalpy, right? I explain you the enthalpy concept. And important thing, Kirchhoff's equation also is here. Very important. Gradually from Kirchhoff's, I took it to a concept called heat capacity. Okay, in heat capacity, you have 2 things, right? Heat capacity at constant pressure, heat capacity at constant volume. Both the formulas I have given. After that, what is the relation between Cp minus Cv is equal to R? And if you take 1 gram of a substance, what is the formula? That is also given. And next important thing, adiabatic expansion of an ideal gas. If the particular gas is undergoing adiabatic expansion, what is the term? Done. Then after that, what is molar heat capacity? What is the definition of specific heat capacity? Like that, the whole chapter is covered in this particular summary. Then last but not the least, enthalpy, that is your thermochemistry. We'll be studying about thermochemistry. Basically in thermochemistry, your Born-Haber cycle. Now students, yes, so I took you into a concept called thermochemistry, explaining the different types of what actually is, enthalpy of a reaction, what actually is standard enthalpy of a reaction, enthalpy of formation, combustion, enthalpy of neutralization, enthalpy of solution, enthalpy of atomization, enthalpy of hydration, vaporization, sublimation, condensation, enthalpy of fusion. So everything is included under one page and one video. Got it? Next, from there, I took you into a concept called bond energy. Okay, what is the formula for bond energy? Summation of the bond energy of reactants minus summation of bond energy of products. Correct? Then I took you into Hess law of constant heat summation. Then I took you into Born-Haber cycle, the whole chapter, then the whole cycle. From there, I have shown what actually is Born-Haber cycle, which involves ionization enthalpy, lattice enthalpy, bond dissociation energy, enthalpy of atomization, and enthalpy of formation. Done the summary. Okay, from there, after taking that, then I gave you the concept of entropy. Entropy is nothing but the disorderness of the system. So what is this? You have two formulas. One is entropy of fusion and one is entropy when it is reversible reaction. Then we are going to learn about a concept called Gibbs free energy. What is Gibbs free energy? The definition I have given, the formula I have given. When it is non-expansion, what is the formula? And if the Gibbs free energy is negative, maximum useful work would be there. So then comes Gibbs free energy and spontaneity. This is a particular thing where you have the different formulas, like, if delta H is positive, what will happen to this one, delta S, and how is the reaction? Like that, I have taken different parameters and I have given you the sum. Then Gibbs free energy change and equilibrium. This is a at equilibrium. So this is a formula for calculating delta G, and that too at equilibrium also. And I've also given you according to the law of mass action. Done. After that, I ended almost the last part. That is Van 't Hoff's equation also I've given here, and second law of thermodynamics also I have given here. So with that, the whole chapter summary would be completed, students. Everything is completed, like, the complete summary, which is including. But little bit more, if you want the third law also, I am going to do it in the next this one. But as of now, till here, this whole thing, that's a summary of the whole chapter, summary in one shot. Everything is complete. So please go through the whole thing, take a printout and note it. Now, let's start solving the questions. Yes. This was a question which was asked in NEET 2020. Let's see. The correct option for free expansion of an ideal gas under adiabatic condition. Okay, under adiabatic condition. That is what they asked. First, let us understand. They said free expansion of ideal gas. Okay. Next important, adiabatic condition. So remember always, students, whenever they say for free expansion of ideal gas, okay, that means expansion means, okay, of ideal gas, that's nothing but they're talking about P expansion, right? That's free visit, that's free expansion, that is nothing but 0. So we apply it in the formula, W is equal to minus P expansion delta V is equal to 0. So they said that is adiabatic process. So in adiabatic processes, what is students, in adiabatic processes, the most important thing, Q is equal to 0. Now applying according to first law of thermodynamics. So what does first law of thermodynamics say? First law of thermodynamics says that, yes, first law of thermodynamics, according to this, what is the formula? Formula is delta U is equal to Q plus W. Now you only see Q factor is, now this is 0. Now you only tell me as the internal energy, what to remember here, what is the trick here? Important trick, important thing. Remember, students. Remember, as the internal energy of the ideal gas, IE is internal energy of ideal gas, is a function of temperature. Correct, na? See this. Internal energy is a function of temperature. So when internal energy is a function of temperature, remember, students. Remember, if delta U is 0, total delta T also is 0. Perfect. Yes, that is what is the concept. So internal energy is a function. That's why this is 0. This is also 0. Now go back to the question and see. The correct option for free expansion of the gas is what? Yes. Delta Q is 0. Delta T is 0 and W also is 0. Easy. That's because it is adiabatic condition. And that too, it is free expansion of gas. Easy. Chalo. So that is a question. Now let us see one more question for that. Right. Next question. A monoatomic gas X and a diatomic gas Y. Okay. Both initially at the same temperature and pressure. Okay. Done. Are compressed adiabatically. Done. From volume V to V half. Okay. They are compressed itself from the volume V to V half. Done. Which gas will be at higher temperature? Okay. X is given, Y is given, both are same are given. Can't say. Let us solve. So when they say adiabatic compression means the gas is compressed adiabatically means there is a formula which we have seen already. What is that? We have T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. This is the formula which we have, correct, which you've already seen in the summary. Now take the ratio. I'm taking all the T terms to one side. Done. I'm taking all the V terms to one side. Done. Now this is gamma minus 1. Now, which is equal to T2 by T1, which is equal to, so all the bases, can I make it common, students? Here, V2 and 2. So this becomes equal to 2 gamma minus 1 because they said it is going to convert from V to V half, they said. Correct, no? V to V half, they said. So now what happened? What are you observing? Observe here. Gamma is more for gas X. Yes or no? Gas X. See this one. V1. So if gamma is more for gas X, this is the trick. Remember, if gamma value is more for V1, if it is more for gas X, temperature will also be more. Temperature will also be more for that. More for X. Yes or no? Yes. So what is the concept? Just taking the ratios, finding out which value is more. Go back to the question now. And monoatomic gas, now which will be at higher temperature? Just now I said, as gamma is more, the temperature also is more. Perfect. So X constant, X is the answer for this. Done. Let's see one more question. A sample of oxygen gas expands its volume from 3 liters to 5 liters. Okay, expansion is 3 liters to 5 liters. Done. At constant pressure of 3 atmospheres. Okay, the pressure is 3 atmospheres. This it is expanding. If the work done during the expansion is used to heat 10 mole of water initially, present at 290 Kelvin, its final temperature would be what? Okay. They are basically asking me TF. This is what the final temperature they're asking. Done. Now, what did they give me? They have given me the expansion part. How much did it expand? It is expand 3 liters to 5 liters. 3 to 5. The expansion part is how much? It is expand from 3 liters to 5 liters. Okay, this is one given. Anything else is given? 10 mole. Okay. So if the work done during the expansion is 10 mole. Fine. Now let us start solving. So first of all, the question is work done in expansion. Okay, what is the formula, student, when work is done in expansion? It is P delta V. Done. How much is the pressure they have given me? They have given me 3 atmospheres. So pressure is 3 atmospheres. How much is expansion? 5 liters minus 3 delta V, because 3 to 5 has gone. Na? So 5 minus 3 is 2 and 3 atmospheres. So it is 6 L. This is L, na, students, volume. Na? This is liters. So L80. This is clear, I think. This is clear. Okay, 6 L80. Now, what do we have? So for 1 ATM, how many joules, 1 liter of ATM, how many joules of work is done? We know, na? What do we have? We have for 1 L ATM, how many joules of work? 101.3 joules of work. So for 6 ATMs, so for 6 LATM, how many joules of work done means what? Cross multiply. How do I get? I get 6 into 101.3 joules. Easy. So how much do I get? I get an answer of 607.8 joules. That's all. This is what we have. Now, I have to find TF now, students. Now remember. So there is one formula. First of all, let us assume temperature change. First of all, delta T, let us make delta T. Okay. Let this take as a temperature, and this will be change in temperature of water. Change in temperature of water. Okay, done. I have taken this. Now, what is the formula? We have one formula. P delta V is equal to M into C into delta T. This is one formula which we have. Correct, right? Now observe how much did we get P delta V? Yes, we have got 607.8 joules. How much is the mass? How much is the mass? Right? They said like oxygen, sample of oxygen expands, they said. So the molar mass of that, so 180 into C. How much is the C value, students? C value is because specific heat, they've already given a C specific heat, 4.184 into delta T, I don't know. Yes. So this whole thing, if you multiply, you'll be getting an answer of around 0.81 K, around that. 0.81 K is what you get. Delta T. So what should I find out? I have to find TF. TF is equal to what? T initial plus delta T. This is what we got, delta T. So how much is this, students? How much is this? If I calculate, already I have got delta T value here. T initial we know. Yes. So if I add and do it, I'll be getting TF answer as 290.8. Okay. Check. Easy. So go back to the answer. Option is 290.8. Okay. Little difficult but easy question. Let's see. Let's see one more question. Easy. One more. For A to B, delta H is equal to 4 calories per mole. Delta S is 10 calories per mole inverse. Calorie inverse. Is the reaction is spontaneous when the temperature? Oh, they're asking you when is this reaction spontaneous? Remember, students, how to do this sum. Check. Let me take the next page and see. Okay. So basically, Gibbs free energy, how can it be expressed? Why did I take Gibbs free energy? I'll tell you. How is the delta G is equal to delta H minus T delta S. Now, when delta G becomes 0, okay, what will the equation be? So this is equation 1. So equation 1, how does it write? Equation 1 can be written as T is equal to delta H by delta S. Correct now? This is what? Oh. So how much is delta H given to me? They have given 4 calories. How much is S given to me? 10 calories per mole. Correct? So can you substitute it? T is equal to 4 by 10 into 10 raised to the power of minus 3. I just converted. So when I multiply this, I'll be getting into 0.4 into 10 raised to the power of 3. It is nothing but 400 Kelvin. Okay, I calculated this. Now, how to tell whether the reaction is spontaneous at what temperature? Remember, what is the trick, students? What is the important trick? Remember, students, important. If T value is more than 400 Kelvin, then delta G is negative. If delta G is negative, reaction is spontaneous. So remember this concept. So how much did I get? I got answer more 400. Easy. So now you only tell me here the reaction is spontaneous when the temperature will be more than 400, I said. Correct. It should be more than 400 means this is gone, ruled out, this is gone, ruled out, this is also ruled out. So if the reaction will be, it is nothing but 500. So it should be more than 400, then only the reaction is, or the Gibbs free energy would be negative. Easy? Yeah. Next question. Let's say this. At particular temperature, H plus OH minus and water, H plus OH minus and OH minus gives water. Okay, delta H value is so much. The approximate heat evolved when 400 ml of 0.2 molar sulfuric acid is mixed with 600 ml of 0.1 molar KOH solution. What is it? What did they ask me? They asked me to find out heat evolved. Correct? So I have to find out what is the heat evolved. Okay, done. Let us see how to solve this question. First of all, which is given to you? Sulfuric acid is given. Done. Let's start solving the question. First of all, calculate number of equivalents of sulfuric acid. Why? Let me show you. Equivalents of sulfuric acid taken. Okay. So here, how much is it taken, students? What is the concentration? It is nothing but 0.2. Okay. 0.2 into number of H plus ions is 2 into how much did they give me? 400 ml is a volume divided by 1000. This is the equivalent, which comes around 0.16. Yes. Now, same like that, find for number of equivalents for KOH. Equivalent of KOH added. Let us taken or added. So, let us take that. How much did they give me? They've given me 600 ml. Okay, 600 ml into potassium. OH minus ion is only one, students. So, nothing. What else is there? They have given me 0.1 molar. So, 600 to 0.1 divided by 1000. This comes to 0.06. Done. This is one answer. This is one answer. Now, they asked me to find heat evolved. Important. The number of equivalents of acids and base, at what temperature they neutralize? They neutralize it 0.06. Correct? Na? Now, check number of equivalents of acids and bases. Which neutralize each other at what time? This one point, which neutralize is 0.06. Correct now? Done. Now, so what is heat evolved now? Simple, easy. Heat evolved is equal to check 0.06 into how much is this on the set? Delta H is minus 57.1. Okay, so 0.06 is 57.1 kilojoules. So this comes to around 5.665. Okay, it comes around to 3.42 kilojoules. This is the answer. This is how you calculate heat evolved. Go back to the question. Where is the answer? The answer is this. Easy. So I got 3.42 426 kilojoules. Easy, students? Easy. Let us see one more. Okay, this is given in 2017 NEET question. Let's see. A gas is allowed to expand in a well-insulated container against a constant external pressure of 2.5 atmospheres from an initial volume of 2.50 liters to final volume of 4.50 liters. So what should I find out? The change in internal energy delta U of the gas in joules. So I have to find delta U of the gas. I have to find in joules. This is what I have to find out. Correct na? Now check. Easy question, nothing else. Easy. Let us solve this. First of all, as soon as the question is given to you, try to pick up the question. Try to write the whole thing and answer this. So shall I give you as an homework, students? Will you try this? So this question is easy. I have given I'll also give you a clue. So try to use a delta H formula in this. Okay, delta H formula also, if you use, you will get it. So will you try? So try this in comment section. Try and mention your answer in comment section. Mention your answer in comment section. If you try this answer in comments, I'm going to pin your answer. I'm going to pin your answer forever. It will be there. It will be pinned in the under the video. Pinned answer. It will be pinned. It will be there forever in your answer will be pinned. Chalo, good. Let's see. Try. One more question. So hydrogen has an ionization enthalpy, has an ionization energy of 1311 kilojoules per mole. Chlorine has 1256 kilojoules per mole. Now, hydrogen forms H plus ions, but chlorine does not form Cl plus ions. Why? What did they give me, students? Remember one clue. What is the trick here? Always remember hydration enthalpy, okay, or hydration energy. Remember, if the hydration energy is less, means less, if you're comparing, then automatically formation of ions is difficult, na? Correct, na? Formation of ions becomes difficult. So if I take this concept, you only observe H plus has ionization enthalpy of okay, ionization enthalpy is 1311 kilojoules. Cl minus is 1256 kilojoules per mole. But what did they say? H plus forms. So important. Ionization enthalpy is something which is dependent upon the hydration enthalpy, because when you dissolve, you're trying to take out one electron and you're trying to form an ion in water only, the students. Yes. So how does this go about? So remember, chlorine has lower hydration enthalpy. That's the reason it does not form ions. Just now we have mentioned, na? Lower the hydration enthalpy, lower is the possibility to form. Okay, so right. So hydration enthalpy of chlorine is very less compared to H plus. That's why it does not form Cl plus ions. Next question. This is given in 2004. Try considering entropy as a thermodynamic parameter. Okay. The criteria for the spontaneity of any process. Okay. What is important? Check. Do I have place? Okay, I don't have place. Let me do this. Careful. So there are 4 conditions given to me. They're asking you what is the criteria for spontaneity. So always remember, students, if you want a spontaneous reaction, or if you have to say what a spontaneous process, remember delta S total is always positive. It is always positive. Remember this. It should be positive, then automatically the reaction is spontaneous. You only check the delta S is system plus surroundings. System value and surrounding value is more than 0. Is it not positive? It is positive. Then if the reaction is it's more positive, means this particular reaction is more spontaneous. It's more spontaneous. So the correct option is next question. Match, this is given in 2010. Match the list equations list with list 2, list 1 and list 2. Okay, 1 second, students. 1 second, please. All right, students. So let us start off with the topic again. Right. So what should I do? I have to match list 1 and list 2. Okay. So first of all, what to remember? Always check. For a particular reaction, any clue if I have get. So we already discussed about spontaneous reaction means what? Spontaneous, endothermic, equilibrium, non-spontaneous. So one thing I'll tell you, always remember, when Kp is greater than Q, okay, this one condition, one trick you remember one. So that means if Kp is greater than Q means, what is this concept? Rate of forward reaction is more than rate of backward reaction. This is what is the concept. Okay, rate of backward reaction. Now you only see. First of all, if rate of forward reaction is more than the rate of backward reaction, the reaction is spontaneous in nature. Okay, the reaction is spontaneous in nature. Okay, so remember. So what is the first concept? So A, one part. Do I have place? Okay, do I have place or no? No, I don't have place. Okay, let me take this in the second case and then I'll tell you. 1 is matching with 4. Okay, done. This is done. Let us go with the second part, students. Second part is if delta G naught is less than RT ln Q. Remember, then careful, RT ln K is less than RT ln Q. Remember, then K is less than Q. This is the concept. Okay, right. So then what will happen if K is less than Q? What will happen, students? What will happen? The reaction will move in backward direction. Correct, no? Will move in backward direction. Yes. So when the reaction moves in backward direction, what will happen to the reaction, students? Then the reaction is spontaneous, is non-spontaneous. The reaction is non-spontaneous. Check this. Check. So what is that? The second part rather. So go back. So sorry, go back. If delta G naught is less than ln Q, the reaction is non-spontaneous. So 2 is equal to 1. This is clear. Okay, let us go to the third one and see. Third concept. P delta S is greater than delta H. Remember, then what will happen? Delta H will be greater than 0. T delta S is greater than delta H. Then delta G is less than 0. Then what will happen, students? Then the reaction will be endothermic and the reaction is spontaneous in nature. So please check this. This is one more concept. So third one, what is it? Basically, go back to the question. So third one is equal to, no, yes. So basically T delta S, no, we have written. So fourth one is nothing but equal, your T delta S is greater than delta H. Fourth one is equal to third concept. Now what is left out? What is left out? Third one is directly equilibrium. So third one is equal to, easy. That's so one clue. So remember, these are all the tricks which you should remember for church. Easy. Done. Next question, students. During isothermal expansion of an ideal gas, what happens? It basically internal energy increases or enthalpy decreases. What actually is this? Remember, always during isothermal expansion of ideal gas, what is it? Delta T is equal to 0. Delta E is equal to 0. Therefore, what happens to delta H also, enthalpy change also is 0. So, check. According to the formula, H is equal to E plus PV. Now change they asked. So, since delta H is equal to delta E plus PV, change. So now what do they say? Gaseous. So in terms of gaseous, how do we write? We write in terms of number of moles of gaseous in reactants and products. Delta N we write. So now you only see delta H is equal to delta E plus, if I can write further, can I write like this? Can I write NR delta T temperature? Now you only tell me, go back. Delta 2 is 0. Delta E is 0. Now substitute that value. In this question. Delta E is 0. Delta T is 0. So what will happen to delta H, students? Delta H also is 0. Correct. So change in enthalpy is 0 means, what does it mean? So basically the enthalpy remains unchanged. Enthalpy remains unaffected. So when the enthalpy remains unaffected, what option should I take, students? Go back. See this. During isothermal expansion of gas, yes, all are zeros. So enthalpy remains unaffected. Easy. This question was given 94 and 91, please check. Next important question. This question was given in 2009. Check. From the following, they have given the bond energy of hydrogen atom, bond energy of carbon, this again carbon, then CH bond. So this is the reaction given to me. I have to find out. Now, so such question is given to you. Calculate, start solving it. Okay, so how to do it? So first of all, what is given? I have to write the formula for enthalpy of reaction. Enthalpy of reaction. How can I write enthalpy of reaction formula? Summation of bond energy of reactants minus summation of bond energy products. Is it okay, students? Done? Done. All right. Now, what are there in the react product side? This one. What is there on the reactant side? This. So write a note like that. Expand summation of bond energy of carbon double bond C, done, plus bond energy of hydrogen single bond hydrogen, these are the reactants, minus of, so basically products right. So one more is also there in the reactant side, bond of carbon and hydrogen also is there. See this is also there. I should add that also. Yes, so plus 4 into bond energy of carbon and hydrogen. And this is my reactant side. Subtracting bond energy of carbon and carbon plus 6 into bond energy of carbon and hydrogen. Done. This is what I wrote. Why did we write 4 and 6? Why did we write 4 and 6? Right? Can you tell me, student? Can you tell me in the comment section? Let me see who is going to answer. What is that? Okay. Let me see who is going to answer this part and this part. Try. Now substitute the values. For carbon and carbon, how much did they give? 606. So write on that. 606 plus. Then for hydrogen, 431.37 plus 4 into, how much is given for carbon hydrogen? It is given 410. 410.50. This is for the reactants, subtracted by the products. Carbon 336.49 plus 6 into 410.5. That's all. When I subtract this whole thing, when I simplify this, I think I'll be getting an answer around minus 120.02 kilojoules per mole. Check kilojoules per mole. This is what is the answer I get. Yes. So means basically if I subtract this, how much do I get? I get 2006, I think around 679.47. If I subtract this, I will be getting an answer of 2999.49. That's the reason. Smaller number minus bigger number. The correct answer is minus 120.0 kilojoules. Next question, let us see. Yes. This is given in 2012. Check, very important question. The enthalpy of fusion of water is 1.435 kilocalories per mole. The molar entropy change for melting of ice at 0 degrees. Okay, molar entropy change. Let's check this and see. Okay, so basically here I'll give you like one important thing, students. Whenever a question is given to you, once recollect the formulas. It's easy for you. What did they ask me? They asked me molar enthalpy of entropy change for melting. That is delta S they asked. Correct? This is what I have to find. What did they give me? Fusion they have given me. It is 1.435 kilocalories per mole. What is the formula? The formula is, let me take delta S fusion is equal to fusion by T. Now substitute delta S fusion is equal to 1.435 into 10 raised to power of 3 divided by fusion is 273. It comes to delta S fusion is equal to 5.26, around 5.26. Yes, calorie per mole Kelvin, around this. I already worked out, so it is easy for me to give you the answer. Go back to the question and mark it. 5.26. Done. Next question. Let us see one more important question. This is given in NEET 2017. Let's see. For a given reaction, delta H value is so much. Okay, delta H value is given to me 35.5 kilojoules per mole. Delta S value is given to me 83.6 joule Kelvin inverse mole inverse. They're asking me the reaction is spontaneous. Assume delta H and delta S do not vary with temperature. Okay, this is what they are saying. Means they are giving you the reaction is spontaneous. Okay, so first let us analyze for a spontaneous reaction. Okay, so what are this is basically delta G has to be less than 0. It should be negative, correct? If delta G is less than negative, delta H minus T delta S also is negative. Perfect. Done. That means T is more than H and delta S. Now, what value did they give me? They have given me delta H value is this, given. Delta S value is this, given. Substitute it. Now, substitute in the question. Delta T is greater than, how much is delta H? 35.5. How much is delta S? 83.6 into 1000. Which will come around, when I did, it was 42.6, 424.6. So approximately how much? Rounded off figure, 425 Kelvin. Now I said, therefore, temperature is more than 425 Kelvin. So they are asking you, go back, see this. So assuming the delta H does not vary, the reaction is spontaneous at what? What I said, na? The reaction should be will be spontaneous if the temperature is more than 400. So it is 425. If it is more than 400, if the delta T value, if it is more than 400 Kelvin only, the reaction is spontaneous. Easy? Next question. This is given in 2010, All India Pre-Medical Test. Check. Standard entropies of X2, Y2, XY3 are 60, 40, and 50 respectively. For the reaction, this is the reaction which is given. Delta H value is so much. The temperature should be what? No, now let us understand the question. They are asking me to calculate what is the formula. T is equal to delta H by delta S. Done. Now, first of all, let us solve the equation. This is the equation given. Let us solve the equation first. See this. At equilibrium, delta G is equal to 0. Delta H is equal to minus 30 kilojoules. This is what is given to me. Done. Now, entropy of the reaction. Entropy for the reaction. What is it? Delta S is equal to delta S products minus delta S reactants. Am I right? Am I right, students? Yes, this is the thing. Now substitute. How much is the product side? Product side is, okay, if I take it is 50, correct. And coefficients are there, half for the reactant and 3/2 for the reactant. So how much did they give me? X2, they have given me 60, and the coefficient for X2 is half. Y2, they have given me 40, and the coefficient is 3/2. XY3, they have given me, that is 50. No, there's no coefficient. Let us substitute that, come back. So delta S is equal to 50 product side minus half into 60 plus 3/2 into 40. Correct, na? Then when I solve this, I'll be getting around 40 joule Kelvin inverse mole inverse. This is my delta S value. Now substitute. I have to find out what T na. So right, T is equal to delta H by delta S. Now substitute. How much is delta H given to me? Minus 30. Okay. How much is delta S given to me? 40. Minus 30 into 10 raised to 3 divided by 40 J Kelvin inverse mole inverse. Done. This is joules. So when I solve, I'll be getting around 750 Kelvin, which I already know. So the answer is this. Easy, easy. Next question. Let's see. 3 moles, this is given again in 2010. 3 moles of an ideal gas expanded spontaneously into vacuum. The work done is simple, student, simple. I'll tell you. What to remember? They said gas expanded. Always check as ideal gas is expanding. That too what? This ideal gas is expanding into vacuum. Okay. Then it is when it is expanding into vacuum, remember P external is 0. That's first. Now what did they say? Work done will be. So remember, what is the formula? This is first point. What is the second point? Work done is given by, what is the formula given, students? What is the formula given by? What is the formula? W is equal to minus P external delta. Now P external is 0, na? P external is 0. So when P external is 0, what will happen? W is equal to minus P external delta V. So this factor is 0, means the whole factor W is equal to 0. So the answer is this. You see? Next question. Reversible expansion of an ideal gas under isothermal and adiabatic conditions are shown in the figure. They have shown you the conditions. Those are reversible expansions. So what did they ask me? They said AB is isothermal expansion, AC is adiabatic expansion. Which one of the following options are incorrect? Which is incorrect? Okay. So what to remember, students? Check carefully. They said A to C graph, what is it? It represents adiabatic reversible expansion. Am I right? So when it is adiabatic reversible expansion, yes, work is done on what? On the expense of internal energy, because work is done on the system now. Work is done on the expense of internal energy. The change in internal energy is going to happen. So when the work is done on the expense of internal energy, what will happen? What will happen? Automatically, when, okay, once again we will write work is done on what? You're expending internal energy inside, expend at the expense of internal energy. So when you're doing work on the internal, means in the system, automatically there is the amount of internal energy which is used up. So what will happen? Because of this, internal energy decreases. Correct? Because you're doing work, internal energy decreases. When the internal energy decreases, what will happen? Temperature also decreases. Easy. So that's why, yes, that's why your character, that is your TC, right? If I take TC is less than T. Check. TC is less than T. See? Easy. So they have given you adiabatic reversible conditions, adiabatic reversible expansion. So back to the question. TC is basically the factor less than which one, students? Which one? That is, so TC will become the system be less than the TA factor. So which answer will match? Temperature decreases. So TC will be greater than your TA factor, because you've said you're expanding it. Got it, students? So basically, this concept easy, right? Done. So internal energy, okay, I think the concept is clear. Now let's start with the next question. Okay, identify the correct statement regarding entropy. Okay, at absolute zero of the temperature, entropy of a perfectly crystalline substance is taken to be zero. Yes, which first answer only I got it correct. What did they say? According to third law of thermodynamics. What is it, students? According to your, according to third law of thermodynamics. What is the concept, students? What is the concept? The concept is entropy of perfectly crystalline substance. Entropy of perfectly crystalline substance at absolute zero. At absolute zero. At absolute zero temperature is taken to be zero. Taken to be zero according to your third law. So according to this, see the first option, perfectly crystalline substance. Yes, this is what your third law says. Directly, I got the first answer right. Next question. Given the following entropy values here at 298 Kelvin and 1 atmosphere, hydrogen is given, chlorine is given, HCl is given. So what should I find out? The entropy change I have to find. I should find delta S means what? What is the formula? Delta S is equal to delta S product minus delta S reactant. Correct, no? Then substitute. Here product coefficient is 2. There are no coefficients on the reactant side. The values are given, easy to substitute, substitute. Delta S is equal to product coefficient is 2. The value given is 186.7 minus 223 plus 130.6. Then, so if I calculate, how much will I get? 2 into 186, 373. And 223, 130, it will become 353.6. So if I add a delta S is equal to, okay, it is Kelvin mole inverse. Okay, right. This is your entropy change. Go back to the option and check. Yes, the option is almost plus 19. Perfect. Right? Okay. All right, students. So we've come to the end of your thermodynamics. All these questions are very, very, very important questions for your exam. Very, very important questions. So please go through. I'll be coming back with one more NEET series. Next chapter, I'll be doing chemical bonding. So thermodynamics, that chapter I've covered all the topics with the summary. So please share the video, please like the video, please follow the channel, give your comment. I've given you one question also, and turn on the bell icon. I'll be back with one more important series. So thank you for watching. Always keep smiling, and all the best. Vani ma'am back with one more important series. Signing off. Bye bye. Thank you.